Okay, this is going to take some more effort, but basically what we want to do is we want to run this all over the place, okay? So here, instead of just, say, running it on C equals 0.25 to, or 0.25, 0.25, I want to change these numbers. So I actually want, say, this to range from, I think I'm going to go -2 to 2, and I want this to range -2 to 2, and then I want to do the checks. Okay, so I'm actually going to take this code and I'm going to put it down here for no specific reason except that I feel like it. Okay, so this is going to go actually inside a for loop. Okay, so let's start by saying I want to go, so let's make X and Y points. So the X points are in your real axis and your Y points are in your imaginary axis. If you're on a complex plane, if you don't know what I'm talking about, complex plane is just like this. So this is fun. This is your real axis, X is your real axis, and I is your imaginary axis. And when you have, 1 plus I, it's kind of like that I hat and J hat if you're doing physicsy stuff, real and imaginary. Okay, so let's say that I want to go from -2 to 2. So let's just start, and I can't do, thank you, that's creepy, but I think it's because I already typed this out today. If I can't do -2 to 2, first of all, that would only give me a very, very small number of points. It would just give me 3 points, 4 points, I'm not entirely sure how Python handles it. So what I want to do is I want to do linspace, but I don't think that linspace exists by itself. Let's just say I want to do 100 points from -2 to 2. I'm going to comment this out for a second. I think this is going to give me an error. Yeah, linspace is not defined, and that's because linspace is in the NumPy library. So NP linspace, now this doesn't tell me what I'm going to get, but if you want to see it, I can print X and it'll show me there's all the numbers between -2 and 2. Okay, so let's do it again for Y, NP linspace. Okay, so I'm going to make 100 numbers in each direction. Then what I'd like to do is I'd like to go ahead and determine whether or not these are Mandelbrots or not. Okay, so I'm going to have, in this case, 100 by 100 matrix. You know what would be easier is I've got too many hundreds. Let's pretend this is just 10 by 10, which is still technically 100, but it's different. Let's just call this num points is equal to 10. So I can go here, num points, and then here, num points. And what I'm going to do is I'm going to pre-allocate my set of 0 matrices, or a matrix of zeros. And again, in MATLAB, that's going to be NP zeros. And then you have to have 2 parentheses that say num points, num points. So that makes me a 10 by 10 matrix of zeros. But again, it's still zeros, but I have to import the special library, the NumPy library, the NP library, in order to get those zeros. I just love how it's so helpful. I'm trying to discover things with you, but just I can't because it keeps suggesting things. Pre-allocate for speed and efficiency. Okay, so there we go. So basically what I want to do is I want to go from, I want to go through each one of these on its own. So I'm just going to do a for loop. For I in range num points. Thank you. I just typed all that out. Okay, untype all that out. For I in range, so this is going to give me, I want the A value to be xi. Okay, so that means the real part, so usually whenever you do a complex number, it's written as A plus BI. So the A is the real part, so I'm going to take that from the x-axis. And then I'm going to, again, for J in range num points, and then the little colon, I want b to be y at j. Okay? So once I've done that, the new point C is a plus b times 1j. So remember we said that you can't just say j, you have to say times 1j. Okay, so now it's suggesting very helpfully that I just do this, and if I did this and I moved on with my life, I would be sad. Because if you think about what's going on, we're talking about things in terms of x and y. And this is talking about things in row and column. Now, if you think about it, row is actually the uppy downy part, and column is how much you move left to right, which is actually backwards. So row column, because we're doing this specifically for graphing, row column is actually yx. So when we put this in, we need to go ji, not ij. Okay, and that's like one of the trickiest things that you can have. Okay, so now in theory, if I run this, I should get a Mandelbrot check for each one of these. So let's see if I just run this, and then maybe I'm gonna print M because it's just 100 by 100. Let's run this and see if I get something decent. Look, there's 4 things in the Mandelbrot set, but that's again because I only included a tiny number. If I change this to like 20, I'm not trying to make it so big that you can't see it. There. So if you think about what the Mandelbrot set looks like, Mandelbrot set, so it looks like that with a center and a little point. You can already see that starting to form. Here's our center, and here's our little point. Okay, so if I go to 30 by 30, oh, I can't see it as well. Let's go to 25 by 25. Come on now, 24 by 24. There. Now you can see the ones making that big circle, and then you've got this little circle, and now it's starting to give you more fractally stuff going on, okay? So we have something that's fundamentally working. The next step is going to be to make a print out of it, because we obviously don't want to look at zeros and ones, we want to see a pretty picture. So that'll be the next thing we do.